Hello and welcome back to this channel. Dear students, this is the quick revision session for microwave systems and microwave measurement techniques. So first we will discuss about microwave, terrestrial and satellite communication system. Basically, microwaves are used for wireless communication systems because they can penetrate through the ionosphere. This is the block diagram of microwave terrestrial system. It is a bidirectional communication system. So different blocks are as shown in this figure. We are making use of multiplexer and demultiplexer because at the base station, the data is combination of different types, like it may contain the voice information, then video information and so on. So this data should be multiplexed, then it is converted into microwave signal. Again, at the receiver side, microwave signal is converted back into the baseband signal. So multiplexer and demultiplexers are required. Similarly, different modulation and demodulators are required. Then it is required to convert the frequency upside as well as downside. So UC and DC indicates up converters and down converters. This communication takes place for thousands of kilometers distance usually. So the signal is getting corrupted. So many times the repeaters are required. Then again, same blocks are shown at the either end because this is the two-way communication system. Now, this particular micro-terrestrial system is limited to LOS, that is line of sight communication system. There are many obstacles, like the obstacles that are getting from the buildings, then mountains and so on. So to avoid obstacles, antennas are placed on top of buildings, then some towers are used or antennas are placed on the mountains. This system usually operates in the range 4 gigahertz to 6 gigahertz, but some systems also operates around 2 gigahertz. The characteristics of micro-terrestrial communication system includes they are used for high frequencies. So as frequency increases, the bandwidth also increases and data rates also becomes high. Then attenuation of this thing is given by 10 log of 4 pi d upon lambda. Lambda is the operating wavelength, d is the distance. So it indicates that attenuation is directly proportional to the square of distance. So as the distance increases, attenuation goes on increasing. To avoid this, as I said, there are many obstacles, so attenuation also takes place. Then atmospheric effects, atmospheric conditions also causes effects on this communication system. So it is required to use repeaters after a particular distance. Repeater is a block which accepts the signal, filters out, amplifies the signal and then reproduces the signal again. So typical requirement is that repeaters are placed after 10 kilometers to 100 kilometers distance depending on the applications. Then applications of this terrestrial communication system is long distance communication services, for example telephone, television services. Then for short distance communication, that is point to point link, for example LAN and closed circuit TV. So this is about the terrestrial microwave communication system. This is the simplified diagram of microwave satellite communication system. As such, there are two major parts. One is the space component, which is satellite itself, and another is the ground station or earth station. This is a two-way communication system. So one or two more important terms are there. One is uplink and another is downlink. So different frequencies are assigned whenever the data is passing from ground station to the satellite, and then again the different frequencies assigned for the signals which are passing from satellite to the ground station. So in this case, as I said, it is a two-directional communication. The earth station plays an important role. User enters the data, then data is applied to the terrestrial system. The data is combination of different kinds, like the data may contains videos, then data may contains voice signals and so on. Then the amplification of data takes place. Usually low noise amplifiers are preferred, and up conversion of that data is done by the earth station or ground station, and then it is applied to the suitable antenna. After up converting, after changing its frequency, the signals are transmitted towards the satellite. Then satellite again transmits the signal back to the earth station. This is called downlink part. So such signals are captured by the receiving antenna, then again reverse process takes place as compared to the process taking place at the transmitter side, and the signals are filtered and then applied to the earth station. So this is the simplified block schematic of the micro satellite communication system. The different losses involved in this system in both uplink as well as downlink system are free space loss, that is FSL, then AML, that is antenna misalignment losses, then polarization losses PL, and atmospheric absorption losses AA. So always care is taken that all these losses must be minimized. Now let us discuss comparison between satellite communication and terrestrial communication system. In case of satellite communication, there is a more coverage area. For example, a geostationary satellite with single antenna can cover almost 1/4 area of the earth, where in terrestrial communication coverage area is less compared to satellite communication. Then in satellite communication, there is more degradation of the data in transmitting system, whereas there is less degradation. Delay, as far as this satellite communication is concerned, delay means the signal which is transmitting from satellite to earth and again back to the satellite, that is one round trip, is around 240 milliseconds, whereas in this case it is less. Then transmission cost in satellite is independent of the distance if everything is in the same coverage area, whereas this depends on the distance. In case of satellite communication, they support very high bandwidth and higher data rates. Comparatively, terrestrial communication has lower bandwidth and lower data rates. Next part is fundamentals of radar. This is the simplified block diagram of a radar system. It consists of a transmitter. As the name indicates, it transmits the pulses or it transmits the continuous signal. Whenever such signals are received at the target causes reflection. Those are called echoes and it is captured by the receiver. Accordingly, the range of target or distance of target from the radar transmitter is calculated. There is one block which is called duplexer. See, a common antenna is used. The function of a duplexer is to connect transmitter to the antenna whenever it is transmitting the signal, as well as to connect antenna to the receiver whenever it is whenever the signals are getting reflected from the target. Usually, to measure the range, a unit nautical mile is used. 1 nautical mile is 1852 meters. Now there are two types of radars. One is CW, that is continuous wave radar, or Doppler radar. As the name indicates, this makes use of the Doppler effect. So for any relative motion between radar and the target, shift in the carrier frequency of the reflected waves gives the measurement of relative velocity of the target. So this particular radar type, that is CW or Doppler effect radar, is used for the navigation in case of ships. Second type is the pulse radar. As the name indicates, the transmitter transmits the pulses instead of transmitting a continuous wave. So train of narrow rectangular pulses which are modulated with the sine wave are transmitted. In this case, the distance, that is 2r, because this is back and forth distance, is given by 2r is equals to ct. C is the speed of light and t is the time taken by the signal to pass from transmitter to the target and again come back from target to the receiver section of radar. So this is about the fundamentals of radar. Next part is microwave applications. This is the list of certain industrial as well as biomedical applications. So first and important application is microwave heating. It is usually in the range 300 to 3000 megahertz. This microwave heating depends on the material which you are using. That means the shape, size and dielectric constant of the material, as well as it depends on the nature of the microwave equipment. Then in certain broadcasting techniques, for example, 12 gigahertz for satellite TV broadcasting, this microwave is used. Then for drying of wood, papers, textiles. Then in case of satellite communication, because these microwave signals can penetrate through the ionosphere. Then for the measurement of moisture contents. Then another important application is radiometer. It is used for flood mapping, then atmospheric humidity measurement, then solar emission mapping and so on. Then thickness measurement of certain metal sheets in case of rolling machines. Then Doppler motion sensor. Doppler motion is based on the Doppler effect in which the frequency goes on changing. Then continuous measurement of wire diameter. Then heating of plastic and rubber, and biomedical applications. Important biomedical application is biomedical or medical diathermy, as well as it is used in case of certain cancer treatment processes and so on. So this is the list of micro applications. Next most important part is radiation hazards. From the exam point of view, you may expect the question like this: what are the microwave radiation hazards, what are its types, or what is the effect of microwave radiation on human and how it can be avoided. So basically, radiation hazards means it is risk to the health because of the microwave radiation exposure. We know that microwaves are E and H, that is electric and magnetic field energy waves, which are moving together. This forms the electromagnetic radiation. This radiation generates non-ionizing type of radiation. It has a sufficient energy to move molecules around the atoms. Because of this nature, we are using this microwave energy for cooking of food, as well as this microwave is used in many industrial applications. Now the different types of hazards are: first is hazards of EM, that is electromagnetic radiation to personnel. So it is HERP. The heat due to radiation basically affects the tissues. It causes increase in the internal temperature of the body, because heat micro radiation, whenever it is applied on the tissue, it causes increase in the internal temperature of the body. This effect depends on the dimensions of the body as well as electrical properties of the tissues, and what kind of wavelength or how much amount of wavelength is available as far as this radiation is concerned. Another important part apart from these tissues is lens of the human eye. Basically, lenses are more susceptible to the thermal energy, and if the concentration or if the amount of radiation is more, it may cause contracts. Then body skin also gets affected due to this radiation. It generates the heat energy, and in extreme cases it may damage the body skin. This is about the hazards of EM radiation to the personal. Next, hazards of EM radiation to ordnance, that is HERO. Nowadays we are using modern radio equipments, as well as there are radar transmitter equipments which produces high intensity RF field, radio frequency field. So it may cause the premature, before the decided time period, premature activation of electro explosive devices as far as this ordnance system is concerned. Third type is hazards of EM radiation to the fuel. Due to this radiation, micro radiation, it may happen that the ignition of fuel takes place through the sparks. Then these are the generalized effects of the micro radiation. To avoid such things, first step is apply draping of fabric material. This fabric material consists of nickel and copper material over electrical appliances, because this material has a property to absorb the radiation, and then this absorbed radiation is passed through to the earth. Then use EMF blocking plates. Some typical paints are available in the market. Those are EMF blocking paints. As the name indicates, these paints blocks the EM radiation. Then Wi-Fi is the major source of radiation. So again, in the market, Wi-Fi shieldings are available. So if you place those shieldings, then there will be proper transmission of the internet signals, but the radiation, microwave radiation, will be absorbed. Again, this absorbed radiation will be connected, passed to the ground, passed to the earth. Then EMF blocking window films are also avoided. So by making use of such major things, we can avoid we can minimize the effect of radiation. Next part is microwave measurement techniques. Let us first discuss measurement of S parameters. In normal electrical circuits, impedance, that is Z parameter, and admittance, that is Y parameters, are used, are measured. But In case of microwave, due to higher frequencies, it is not possible to make the measurement of current and voltages at such a higher frequency. So these parameters are not used. Rather, in case of microwaves, S parameters are used. Now there is one device which is called network analyzer, which gives the measurement of S parameters directly. This is the arrangement to measure the S parameter. This is the directional coupler. At one end, we have connected microwave source. This is connected to port number M. Then at port N, a matched load is connected. Incident wave is represented by AM. From the matched load, the wave may be getting reflected back. This reflected wave is represented as BN. All other remaining ports should be terminated with the matched load. Basically, the S parameter is expressed in terms of ratio of reflected wave to the incident wave. That means ratio of Bn to the Am. Then, as I said, this network analyzer directly gives the measurement of the S parameter. S parameter is expressed as SMN, that is S11, S21, S31, and so on. And this is the complex quantity. That means it is having magnitude as well as direction. Next is measurement of microwave power. The basic concept is, if you want to measure the microwave power, then power is converted into heat, and then that heat is applied to certain fluid. The temperature of fluid is measured. This temperature is proportional to the measurement of power. So for the measurement of microwave power, the different techniques are available. To measure low power, bolometer or calorimeter is used. To measure medium power, calorimeter is used. To measure high power, calorimetric wattmeter is used. Now, from the exam point of view, you may expect the question like this: what are the different methods of measurement of microwave power, and explain calorimetric method. So this method, calorimeter method, is applicable to measure the power in the range 10 watt to 50 kilowatt. Again, there are two different types. One is direct measurement. In this case, the increase in the temperature of dissipating medium is measured. This temperature is proportional to the measurement of power. In case of indirect method, as I explained, heat is transferred to the another medium and temperature of that another medium is measured. In direct method, the temperature of dissipating medium is measured. Now, there are two types of calorimeter. First is static calorimeter. In this case, a 50 ohm coaxial cable is filled with some dielectric load. Then this dielectric load dissipates the power, and it is converted into heat, which is directly proportional to the measurement of power. In case of circulating method, in case of circulating calorimeter, the fluid continuously flows through the load, and due to the heat dissipation from the load, the temperature of the fluid, which is continuously circulating, goes on increasing. This temperature is proportional to the measurement of power. So in this case, the temperature of outlet fluid is measured, which is proportional to the power. Next part is measurement of phase shift using double minimum method. This is the block schematic which shows how the phase shift of unknown network is measured. This is the unknown network whose phase shift is to be measured, and we have one adjustable phase shifter. Now, at the input side, we have shown microwave source. The signal of the microwave source is amplitude modulation. A means amplitude modulated. So, signal from the microwave source is amplitude modulated using 1 kilohertz sine wave. It is applied to H plane T. H plane T divides the signal into two parts. Then these are the oscillators. We already discussed in details what is the function of oscillator. Then it's one output. The output of upper oscillator is applied to the unknown network whose phase shift is to be measured. Output of lower oscillator is applied to the adjustable phase shifter. Then these two outputs are combined together again using H plane T, and they are applied to the CRO through crystal detector. Now, in case of CRO, we have two sine waves which are amplitude modulated sine waves. We have to adjust the phase shift of this adjustable phase shifter in such a way that the two signals, one coming from this unknown network and another from this, will be in phase. So whenever these two signals are in phase, that means whatever phase shift we have adjusted will be the same phase shift applicable for the unknown network. So on the CRO, you just have to observe that the two signals coming from unknown network as well as adjustable phase shift will be in phase, so that the phase shift of adjustable phase shifter will be same as that of the phase shift of unknown network. Next is measurement of a quality factor. This is the corresponding block diagram. At the input side, we have connected a micro source. Then resistive pad is used. Output of resistive pad is given to the cavity resonator, whose output is again applied to the detector, and final block is the power indicator, which is used to make the measurement of power. Basically, our aim is to plot the graph of output power, which is measured in dB versus frequency. So you just have to go on changing the frequency of this micro source by keeping the signal level constant. So every time go on varying the frequency, keep the signal level constant, and every time whatever frequency you are changing with respect to that frequency, measure the output power. Then plot the graph. Nature of graph will be like this. This is the 3 dB point. At this 3 dB point, this width, which is called half power band width, is measured. This is denoted by 2 delta. Now the standard equation is 2 delta is plus minus 1 by QL, where QL is the quality factor with load. Now from this we can calculate the quality factor. In ideal situation, QL will be same as Q0, where Q0 is the quality factor without load. That is the quality factor of given microwave device. Now measurement of impedance using reflectometer technique. So this is the basic block diagram. Output of microwave source is applied to the resistive pad. So resistive pad controls this output signal. Then we are using two directional couplers. This stands for directional coupler, forward and reverse directional coupler, which are connected together. Then this is the incident power from the load. You are getting reflected power. Both these powers are measured. This is the forward detector and this is the reverse detector, which are connected to the reflectometer. As I said, you just have to measure incident power and reflected power. Then this reflection coefficient is given by rho is equals to square root of PR reflected power upon incident power. You can calculate this reflection coefficient from rho reflection coefficient S, that is SWR, rather VSWR, standing wave ratio, can be calculated, which is 1 plus rho upon 1 minus rho, and the impedance is related to reflection coefficient as Z minus ZG upon Z plus ZG, where Z is the known impedance of the load, ZG is the unknown impedance. So using this formula, we can calculate we can make the measurement of impedance. So dear students, that's it for this quick revision session. Thank you. Thanks a lot for watching this video.